All right, let's start lesson 5.1. This is our introduction to bonding. Now we are going to spend 1 week on each of the different types of bonding or the two main bondings, but this is an overview before we do our lab. So let's get into some vocabulary. What is a chemical bond? It's the attractive forces between atoms or ions that binds them together as a unit. And in order for bonds to form, they do this because, as we learned about in the last couple of sections, it increases their stability because they want them to be stable. So sorry, if you didn't get that, increases their stability. So a compound can be two elements, which is called a binary compound, such as what we have here for sodium chloride, because there's two different elements involved. Or a compound can be more than two elements. For example, this is called a ternary compound because we have 1, 2, 3 elements that are involved. So these are the two different types of compounds that we will be mostly exploring in middle school. So there are different types of bonds, which is really what we're going to be focusing on. Covalent bonds, which our electrons are shared between atoms, right? Co meaning together. You can kind of remember to think about it that way. We have metallic bonds, which would think of metals. This is where we have electrons. They delocalize in metals and they kind of form the sea of electrons that are moving between the nucleus of those metallic atoms. Then we have ionic bonds. Ionic bonds are when electrons are transferred from one atom to the next. So it moves from one over to the other. And remember, we do this because it wants to form stability. So we already talked about its ionic charges before. All right, let's take a look at what a chemical formula is. When we refer to an ionic bond, we refer to it as its formula unit. So sodium chloride has a formula unit. When we're talking about covalent bonds, we're talking about a molecular formula. So CO2 is a molecular molecular formula. It is covalently bonded together. So we consider this to be a molecule and this more to be a compound. All right, a review on ions. When we have an ion that is a single element or a one atom by itself, it's called a monatomic ion, and that would just be something like Na+. Remember that sodium is in the very first column as an alkali metal, and it has one valence electron. It's more likely to lose its electron and become positively charged. When we have two or more atoms, such as in the case here of NO3, all right, NO3, the 3 on the bottom is the subscript. That is not involved in the charge. The charge always goes at the top as a superscript, okay? So polyatomic ion, this is a polyatomic ion. Nitrate, it has nitrogen and oxygen that are combined together, and it has an overall, this whole thing has an overall charge that is negative and a -1. All right, -1. We know that this is a +1 because there's no 1 there, and we assume that it is 1. Same thing here. This is a -1. This 3 has nothing to do with the charge. Do not get confused. This 3 tells us that there are 3 oxygens. It has nothing to do with the charge. How do you need to know, or what do you need to know about these polyatomic ions? Well, if you will take a look at your reference sheet, on your reference sheet, you will notice that there is a whole list of polyatomic ions. Those are the ones that you will use and know in middle school. The list will grow when you get to high school. Let's do some comparing and contrasting. Let's talk about ionic versus covalent. This is where we're going to spend most of our time, is going over. This week we will finish up with ionic bonding, and then next week when we get back, we will be talking about covalent bonding. Bond formation, how did the bonds form? Well, electrons are transferred from a metal to a nonmetal. That's really important. Now that you know the periodic table, you know what are metals and what are nonmetals. Therefore, an ionic bond is between a metal and a nonmetal. All right, it usually forms a crystal lattice, which structure, right? So some of you that are doing things for Science Expo in terms of geometric shapes and how crystals form, a crystal structure or crystal lattice is how ionic bonds are formed. It is usually a solid at state at room temperature. The melting point is very high, and it's soluble in water, which means it can dissolve. So when we put salt into water, NaCl, it will dissolve in water. Does it conduct electricity? Yes. All right, it conducts electricity when it is in a solution or as a liquid. That means that if you have just salt sitting on the table by itself, it will not conduct electricity because it's bonded as NaCl. Now, if you put that into water and it dissolves, it's going to form Na plus and Cl minus ions. The ions are what's the movement of those electrons in that solution makes it electrically conductive. There's no other properties for an ionic bond that we'll talk about in middle school. Covalent bonds, the differences here you can see are that they're shared electrons. And the most important thing is that it's shared between two nonmetals. All right, so we're looking for two nonmetals here. Metal to nonmetal, two nonmetals. Transfer, shared. Make sure you're looking at the differences between these two. These are considered true molecules. So when somebody says a molecule, they're referring to a covalent bond. Don't worry much about that in terms of middle school. When you get to high school, they'll be pretty much sticklers for those things. It is usually a liquid or a gas at room temperature, and the melting point is low. All right, solubility in water is going to be not usually. Like when we put in something like, for example, sugar, which is a covalent bond, it's going to dissolve in water, but it's not going to break apart into ions, and it's not going to conduct electricity because it's not breaking apart into any pluses or minuses at all. So usually not soluble in water, usually not conducting electricity, and it usually has an odorous smell to it. Keep in mind that most of your body is made up of carbon, hydrogen, and oxygen, which is all nonmetals, and those nonmetals bonded together. It was really important because we want to make sure that it has those melting points that you're not going to suddenly dissolve. All right, how does this compare with a metallic bond? For metallic bonds, they are delocalized among metals. And this is all just between metal to metal. That's it. So all those copper atoms, how they join together, all those gold, platinum, any tin, all those other stuff. All right, the type of structure is called a sea of electrons. I'll show you a picture of this in the next couple of slides. It is a solid at room temperature, and then because it's metal, the melting point is very, very, very high. It is not soluble in water, and yes, they can conduct electricity in any form because they are metal. It's straight metal. And the other properties are just like what we learned back in the last unit on the periodic table, is that they are malleable, ductile, and lustrous, which means that they're shiny. All right, let's take a look at some of these things here. This is what a crystalline lattice looks like for ionic bonds. You can see how it's set up. It's nice and structured. In covalent bonds, we have something like true molecules where they're kind of sticking together. This is a diatomic molecule, which you'll learn a little bit later about in this unit, where it bonds to itself. Here's an example of ammonia and water. And this is the picture of metallic bonding and those sea of electrons that kind of disassociate and float around all of the nuclei of all of the other metal atoms. When we look at bond polarity, polarity is talking about the characteristics of how likely it is to be ionic or covalent. Most bonds are kind of a blend of them or have some characteristics. Some of them are straight ionic, some of them are straight covalent, but sometimes there's a blend of those. In this chart right here, you'll learn a lot more about the electronegativities and stuff when you go into high school, but what you can see here what you can see here is that the difference is in how much they like to hold on to their electrons really determines what kind of character they are going to be. In covalent bonds, sorry about that, some elements are more attracted to electrons, and so this causes that imbalance to be shared, and we represent this by this little symbol, right? This little delta symbol here, meaning that it's got a partially negative charge or a partially positive charge. So this is our compound of water. Water is H2O, so it's got two H's, two hydrogens, and one oxygen. Oxygen is much bigger and likes electrons a lot more than hydrogen does. So what actually happens is that the electrons that are being shared with the hydrogen are actually going to orbit around the nucleus of the oxygen more time than they are going to spend around the hydrogen. Therefore, it creates this imbalance like a north and south pole and creates poles. This is going to be a negative pole and a positive pole. So it has a slightly negative charge towards the oxygen and slightly positive charges down towards the hydrogen. This would be considered a polar molecule. Non-polar covalent bonds are shared equally, which means that there is no charge over it, right? So the symmetry of electrons density is going to be the same, and they're usually identical atoms, because think of them like pulling on a rope. So if we had two people right here and they were, twins or the same size, the same weight, the same strength, all of that stuff, and they were pulling tug of war, they would pull at the same strength. The electrons would orbit around these two nuclei the same because they're both pulling on the rope with the same force. Whereas back over here, when we talk about oxygen, oxygen is bigger than these two hydrogens, so it's pulling the electrons closer to itself. All right, so in polar covalent bonds, which we were talking about with water, they are shared unequally. They have asymmetric density, which means one of them is going to pull more than the other side. So it results in what's called a dipole, or slightly charged particles. So over here, if we have one that's bigger than the other, it's going to slightly pull on it, making this side a little bit more negative, then this side a little bit more positive. They're still sharing the electrons, it's just that one is, using it more of the time. In ionic bonds, we have electrons, remember, that are transferred from one atom to another, so that results in ions. And we have here, when we have something like sodium, Na, that gives up its electron, it becomes a positive charge. That's called a cation. Here's how you can remember that. Cation is positive. T for cation is a positive charge. Anion, ana means opposite, negative, right? Negative charge. So anion, positive, anion, negative, cation, positive, T, right there. That results in the ions. So take a look at all of these different ones. The animation on here is not working, and I won't bore you with it to save on some time. But here's what you should think about. If these are the nuclei and these are the electron clouds that are surrounding the nuclei here, if we're a nonpolar covalent bond, it's like two dogs of the same size. They each are pulling on their bone. They each have their own. So that's it, right? If we have a polar covalent bond, we have one that is bigger than the other, and one is going to take the bone or use it a lot more of the time. If we have an ionic bond, one of them just takes the bone and walks away with it. But you don't want to go too far. It's like loaning someone your pencil, which you shouldn't do, right, this year, is that they're going to use your pencil, but what are the chances that you're going to get that back if you don't stick around and be close to them within the same group? Probably not a lot. So if you're using the pencil and one of you can use it at a time, but if they get up and walk away with the pencil, then you would move down to ionic. So hopefully some of those examples will help you remember the differences. Basic things that you need to know is that nonpolar and polar are covalent bonds. They share electrons. Polar, one shares it or takes it more of the time than nonpolar. Ionic, it's a transfer of electrons. And the only reason why they stay together is because they are electrostatically charged. Negative and positive are attracted to each other. All right, we're going to dive into this more in the lab and see what should be happening in our lab coming up.